Hello, my name is Mike Quest, President and co-founder of Avalanche Products. I'd like to help you better understand how an auto air conditioning system works, as well bring to your attention a possible issue with a TXV valve found on certain vehicles. I'd also like to help you avoid the possible damage due to overcharging. We have designed a basic auto air conditioning system diagram to show you the flow of refrigerant throughout the AC system. The compressor is the workhorse of the system and is where we'll start. It receives cool, low-pressure gas, which is compressed into a high-pressure, high-temperature gas and pumped out of the discharge side of the compressor and flows into the condenser. This high-pressure, high-temperature gas is shown as red with bubbles, indicating it's in a gas state. The condenser does just that. Cool air flows across the condenser, cooling the high-pressure, high-temperature gas, turning it into a high-pressure liquid. As you can see, the gas remains red, high pressure, but changes to arrows indicating it's changed to a liquid. The high-pressure liquid flows through the receiver dryer, having a desiccant bag inside it to filter and absorb small amounts of moisture that may contaminate the refrigerant. On the AC system using an orifice tube, the receiver dryer is replaced with an accumulator, which is located between the evaporator and the compressor. The high side service port is located here, between the condenser and the expansion valve or orifice tube. Next, this high pressure liquid passes through the expansion valve, allowing it to expand and turn into a low pressure liquid as indicated in our color change from red to blue. This low pressure liquid flows from the expansion valve directly into the evaporator, at which point it begins to boil and turn back into a low pressure gas, absorbing heat as it does so. This chills the walls of the evaporator, and the blower motor pushes this cool air through the vehicle's dashboard vents. As you can see, the liquid arrows turn back into a gas as indicated by bubbles. The low side service port is located here, between the expansion valve and the compressor. The low pressure gas then returns to the compressor for another cycle. A number of car manufacturers started using a thermal expansion valve, or a TXV, to make the air conditioner operate more efficiently and give better cooling. The TXV system, as shown in our diagram, has a small temperature bulb located at the outlet of the evaporator, which continually adjusts the refrigerant flow through the expansion valve and into the evaporator based on the evaporator's temperature and pressure. Because the evaporator's outlet temperature is used to regulate the TXV valve, it sets a maximum operating pressure at the evaporator outlet. It then flows through the low side service port, where in many cases is being measured by low side gauge only to charge the system. As refrigerant is added, the pressure on the low side rises until it reaches its maximum operating pressure, which is typically 35 psi or lower. If this pressure level is below the gauge's established correct fill, which is typically over 35 psi, even though the system is fully charged, adding additional refrigerant will not show on the low side pressure gauge, but will build up on the high side and can only be measured using a high side gauge. In these cases, using only a low side gauge can potentially cause too much refrigerant to be added and result in damage to the compressor or other problems associated with overcharging. Well, I trust this has been helpful. From all of us at Avalanche Products, we want to thank you for your business. For those of you who have not yet tried our Avalanche refrigerant, we invite you to take the pressure out of recharging your auto air conditioning system and use Smart Clips technology for the correct fill.